Hello, my name is Ralston Smith, and today I'm going to be taking you through a tutorial on how to run an Autodock Vina simulation on the Hopper cluster at GMU. We'll begin by working with Avogadro, a program that we'll use to build our ligand. So we'll first begin by going to the Build menu, selecting Insert, and going to Peptide. For this example, I'm going to be using the tetrapeptide IEGD. So let's just insert the code. And click Insert Peptide, and it's going to just insert the peptide into the environment. We can scroll around for a better view. And as you can see, I don't know why it always does this, but this hydrogen here is not bonded to the rest of the molecule. So I'm just going to go ahead and delete that. Then I'm going to adjust the pH of my molecule. And then I'm going to minimize the energy. This step helps with the docking simulation because it puts the molecule into a lower energy state right off the bat, so you start with a better conformer to begin with. Okay, it's done. Because I can tell it's done because the delta E is equal to 0, and you can click stop, and then you can save your molecule as a PDB format. Choose your directory. I like to always include the extension as good practice. I'm not going to save this molecule now because I already have one saved here for the purposes of this tutorial, but go ahead and save. And then we can exit out of Avogadro. Next, we're going to be downloading a protein macromolecule to work with in Autodock Vina. So direct the browser to the PDB website. The code for my protein is 1FQ3. Your protein may be different. And you can read more information about the structure of the protein from this paper here. It's normally in this location on the PDB. We're going to go download files, PDB format. And that's going to appear in our downloads folder. There you go. And we're going to want to move this file to the location, the same location as the ligand file that we just created, like this. Next, we're going to move the files that we just got from our local drive to the Hopper by using the terminal window. On Mac computers, you can access this program by using the Spotlight search and typing terminal. On Windows computers, you can use a program like PowerShell. Either way, the command is scp, and then we're going to designate the file that we want to move, and we're going to designate where we want to move it to. In my case, it is this location. And I've already moved my files, so I'm not going to run this command, but this is the command to run if you want to move files from your local computer to the Hopper. So if I hit enter now, it would move the files, but I'm not going to do that. Now we're going to log into the Hopper cluster with the SSH command. The command is SSH and then your student ID at hopper.orc.gmu.edu. When you hit enter, it should set up your profile and log you in. I'm going to change directories to my working directory. And as you can see, we have both files, the macromolecule file and the ligand file. Next, we're going to use the grep command to isolate only the atom molecule types in the macromolecule file, and the command is grep atom. Then you want to include the name of the file you want to find the atoms in. You're going to output that to whatever file name you would like. And in this case, I'm going to choose GZB. And you can see the file has been generated here. Now we're going to view some available modules on the Hopper cluster with the module avail command. And when you type this, it shows every available module that's on the cluster. It's an extensive list. There's a lot of modules loaded on here. If you're looking for a specific module, you can use the module avail command and then type some keywords that are found in the name of the module. In our case, we're looking for OpenBabel, so I'll type OpenBabel, and you can see here that there is a OpenBabel module loaded on the Hopper cluster. So I can type module load and then the name of the program of the module. And you can tab complete. You can hit tab to complete the title of the module if it's available. I hit enter and now it's loaded, and we're still in the working directory. So I'm going to use an OpenBabel command to convert the ligand into a PDB-QT file. So the command is obabel and then the file name and then opdbqt-gen3d-best-p. And I hit enter, and it converts the molecule that I listed in there from a PDB to a PDB-QT file. We can now go to the Hopper online interface to convert the macromolecule from a PDB to a PDB-QT file as well. Autodock Vina only works with PDB-QT files, so that's why we're going through all this. You can keep these at 1. It won't take that long. And it'll queue your job until it's ready to launch. And you can launch Hopper Desktop. And it'll open this interface. You can go to the terminal and find the module we're looking for, and in this case we're looking for Autodock. And you can see there's 3 different Autodock modules. We're looking for Autodock Vina, and the latest one is 1.2.3. So we'll load that. Autodock Vina -1.2.3. And then to open the program, we type ADT. click Remind Me Later, and then you can open the molecule that you want to convert to a PDB-QT. So I'm going to find my Scratch directory. There it is. And I'm going to go into Demo, and we want to convert the GZB PDB to a PDB-QT. Remember, we removed the atom molecules, and we put them into this GZB file. We don't want to use the original file because this hasn't been cleaned. So this one, open. And you can see the structure of the molecule. And then you're going to want to go to Docking, Macromolecule, Set Rigid File Name. Oh, actually, before you do that, you're going to want to add the hydrogens, polar only, charges, add Coleman, and gas tiger. And then you're going to want to go to Docking, Macromolecule, Set Rigid File Name, and then save the file as a PDB-QT. Oh. I apologize. You're going to want to go to Grid and go to Macromolecule, choose GZB, select molecule, OK. And then you're going to want to go to the directory in which you want to save it. And you're going to choose a name. I'm going to go with gzb.pdbqt. So I'm going to save it. Now I can go to Docking Macromolecule, Set Rigid File Name, because I want to save this as a rigid file type. There we go. We're next going to identify the grid coordinates for the box that Vina is going to use to perform the docking simulation. So we're first going to change the color of our macromolecule to something that's discernible from the rest. So I like to choose this blue color. Then we're going to identify the active site ligand, active site amino acids that are going to interact with the ligand. And I like to color these yellow because in the grid box interface there is no yellow. There is green, red, and blue. So if you use those colors, it could interfere with your ability to see everything clearly. So the active site amino acids of granzyme B are histidine 57, aspartic acid 102, and serine 195. So I've highlighted those amino acids, and we can identify the grid coordinates for the box now. We go to grid box, and make this a bit bigger. There we go. Now we want this grid to be over these amino acids because these are the amino acids that are going to be interacting with the ligand. So we use the slider to move the box. Look around this way. And these sliders change the box size, but since we're working with a tetrapeptide ligand, I think 40, 40, 40 should be large enough since it's so small. That looks okay. So we're going to record these numbers, this information, for the Slurm script that we're going to write in the next few steps. So I normally just take a picture of it with my cell phone, and then I have that information for use later. And then we can close this, and we're done with this step. Next, we're going to want to create a Slurm script to run the Autodock Vina program simulation. So right now we're in the correct directory. This is the working directory, and we could use the touch command to create a sample script called script.txt. It could just be a simple text file. I already have a script file in this directory here, and it already contains all the relevant information that we may need. So you always want to start with this line, and then these subsequent lines give information about how the resources of the cluster will be allocated. This is the actual Vina executable script over here. So you can find more about Slurm scripts and how to write Slurm scripts for the Hopper cluster at the Hopper Wiki website. I'll leave a link to that down in the description below. The next step is the final step, and that is to run the Autodock Vina simulation with the Hopper cluster. So we're currently in the working directory, and if we list what's in here, we can see we have the macromolecule PDB-QT file and the ligand PDB-QT file, and we have the Slurm script. So the command to run the Slurm script is sbatch and then the name of the script. And then when it's submitted, it'll give you a job number here, and you can view the status of the job by typing SACCT -X. You can see here that I have a job currently running. I'd like to thank you for watching my video, and if you have any questions, please don't hesitate to reach out to me.